we needed to determine if a disease was associated with a pathogen we already knew about or was in fact an exotic pathogen. And listening to some of the discussion as best I could, obviously I don't speak Spanish, but I understand that there was discussion about IPN virus and concerns about that virus being discharged from fish farms. Well, the scientific evidence is that IPN virus is very widely dispersed throughout the aquatic animal kingdom. It's in octopus, it's in many kinds of fish, it's even been detected in some amphibians. So again, it's a very broad, it's not ubiquitous, but it's a very widely dispersed potential aquatic animal pathogen. And the same thing with the Flavobacter. They are present in the aquatic environment. The important message there is that fish farms do not create pathogens. They do not create pathogens. They're already there. They're someplace. The question in the United States has always been, how do they get into a fish farm? Or how do they get into a wild population or feral population of fish? So when we as we evolved our fish disease program in the United States, we looked at the pathways of entry of pathogens, where, when, and why. We looked at characterizing our risks. So we looked at the degree of risk, the scope of the risk, and the impact of that risk, and is it an exotic or an endemic pathogen? Early in our considerations, we determined that pathogens and disease in aquaculture are a normal part of life. Fish farms, again, do not create pathogens, but they can certainly improve the chances of detecting a pathogen when the fish gets sick. In spite of our best husbandry efforts, farming fish does not stress them, or farming fish does stress them. And physiological stress increases the chance for disease to occur. We also discovered that wild fish are most likely to be carriers of fish pathogens. In the United States, and at the company I work at, Clear Springs Foods, our greatest concern is that wild fish are brought into our biosecure area, that is our fish farms, and because birds have eaten those fish and defecated in our farm, or dropped a fish that they captured in the wild that was carrying a pathogen, dropped it into our farm, we all of a sudden have a brand new pathogen that we have never seen before. That is our biggest concern. So in fish farms, we can create a biosecure system that can minimize potential for pathogens to enter. Some culture systems lend themselves better to biosecurity than others. For example, trout raceway systems can be much more biosecure than others, than open net pens, whether that net pen is in freshwater or in saltwater. Net pens, the challenge with net pens is that all sorts of animals are swimming around those net pens. And those fish, even perhaps invertebrates, can carry pathogens. And these may be fish that you would never think carry a pathogen. IHN virus, for example, occurs in Pacific herring. It can be recovered in Pacific herring. And yet IHN virus can affect salmon. in British Columbia, for example. So the point is that wild or net pens have a greater challenge. We all beat to a different drum, right? So in flow-through raceways like Clear Springs has, we have much greater control over what gets in or what our fish are exposed to. And we take advantage of that. We also discovered early on as the United States looked at this that fishing birds, migratory mammals, and migratory fish can move pathogens from one place to another. The pictures up here, I think I can do this. So, belted kingfisher, sea wolf or sea lion, cormorants, ospreys, they can all get, or we can recover fish pathogens from their GI tract. We have found that when they eat fish that have a fish pathogen, by gosh, they're gonna, the mammal or the bird may not become infected themselves, but so it passes through their GI tract and can move that pathogen from place to place. So we had, in the United States, we had to ask ourselves, how can we better secure our farms? We observed that fish producers that take their fish directly to a processing plant created far less risk than fish producers that take their fish to other areas for stocking in new watersheds. In the United States, some fish farmers grow in their public, so we have public hatcheries in the United States that grow fish for stocking in public waters, in the wild. And we have commercial producers that do the same thing. But food fish producers like Clear Springs, we take our fish directly from the fish farm to our processing plant. So there's a different level of risk in those two types of, two reasons for growing the fish. So concerns about one type of culture method or marketing program cannot apply to all fish farms. That's the reality in the United States. Since the time before our U.S. Civil War, which was in the 1850s, and the Civil War, U.S. Civil War really was 1860, ended in 1864, 1865. The United States has had particular interest in anadromous salmonids. So fish like the Chinook up on the slide there, sockeye, coho, chum, and pink salmon. Well, the anadromous fish move from freshwater to saltwater and back into freshwater. Well, in that process, they can get a pathogen from the saltwater and move it to the freshwater. They can take a pathogen from freshwater and potentially move it to saltwater. Again, IHN virus does occur in the United States. It was probably brought into freshwater environments by the movement of salmon, Pacific salmon, into various freshwater environments. And one of our federal agencies, U.S. Fish and Wildlife Service, happened to bring some, and this is before we instituted rigorous inspection programs, but they brought some salmon eggs into a freshwater hatchery to hatch the eggs, to try to replicate what happens in the wild, which is where salmon spawn in the freshwater, and then the eggs hatch, the baby fish live there in the freshwater for a while, and then migrate downriver into salt water to become adults and to become sexually mature, and they move again back into fresh water for spawning. That's the nature of that fish. My understanding is that in Chile, you now have resident Chinook salmon that migrate from salt water to fresh water. A word to the wise. You have the potential to move a pathogen of salmon into fresh water because of that migration. That's what the fish wants to do. It wants to move from salt water to fresh water to spawn. You also have another fish, and I have trouble pronouncing this, but I know there's been some testing of this fish in freshwater. It's a native Chilean fish, Aplochon marinus, which is it's the same, also known as Anyway, that fish is also migratory. It goes from saltwater to freshwater and then back. So my whole point is that pathogens don't come from fish farms. They come from other places. The question for Clear Springs and in the U.S. for managing those pathogens is what can we do to minimize those from coming in. Another challenge in the United States, we have federal requirements for fish health management, but we also have 50 states. Each of those states can have their additional fish health requirements for bringing fish or eggs into their state. There's certain requirements they may have that are in addition to the federal requirements. So we very early on and this is the experts, and I used to be one, but the experts from the Fish and Wildlife Service, the National Marine Fisheries Service, the U.S. Department of Agriculture, and experts from academics, there were academic experts and fish farm experts, we have worked together and figured out that disinfecting raceway water doesn't mean anything. It's not a useful practice. And so we have focused in the United States on preventing the pathogens from coming into the fish farms or being transferred with live fish as they get moved around from one place, watershed to another watershed. And in the United States, we did have serious discussions about disinfecting effluents. But one of the concerns that was raised is that depending on what you use to disinfect that water, you can create disinfection byproducts. Those disinfection byproducts are known carcinogens. And regulatory people, not really, but they would be shot if it turned out that they had allowed carcinogens to be released into the environment. So that was a non-starter for us in the United States. So various federal and state scientific agencies have spent many years attempting to determine the prevalence of pathogens of various kinds in wild fish, and it's an ongoing effort. The question is, what are the natural reservoirs of infection, of pathogens? It remains an important question. We still know very little about most fish pathogens in the wild. U.S. Fish and Wildlife Service in the United States has a program where they go out, as funding allows, they go out and capture wild fish of all sorts, and they look for different kinds of pathogens. It's a very thorough necropsy, a very thorough virologic analysis and bacteriologic analysis. And so they do find pathogens, and in particular parasites like trematodes and cestodes, in wild fish, but also viruses. So again, in the end, yet early in our history, we determined that the best approach to protect our fishery resources, both farmed and wild, was to prevent the introduction of pathogens into those waters by requiring specific pathogen-free eggs and fish be used, particularly for some odds. So what the United States has basically done is hazard analysis. We've done a hazard analysis where we've developed a HACCP plan, Hazard Analysis Critical Control Point Plan, to address fish health. We've identified 3 particular hazards for wild fish and for farmed. The first hazard is foreign animal diseases, so the exotic pathogens. And we've identified a critical control point, which is to do something to exclude that foreign animal disease pathogen from coming into the United States. For emerging diseases, diseases that are still struggling to define exactly what an emerging disease is, but diseases that maybe are in the United States and for whatever reason, a bird flew over the wrong way and dropped a sick fish or pathogen-infected fish, and it started to occur in a particular state or region of the country. How do we stop those? That's a hazard. How do we prevent that from becoming more of a problem? Again, key point is to exclude it from fish farms from wild populations of the fish, and to institute a surveillance program of both farmed and wild fish. And then in the United States, we have very limited treatments that we can use to treat sick fish. Antibiotic use is a concern. I know it is in Chile. It's a concern in the United States with all of animal agriculture. So we've instituted judicious use guidelines that are being implemented primarily by veterinarians, licensed veterinarians in various states and in practice, and they ensure that fish farmers in the United States do not overuse antibiotics. And again, in the United States, you really only have 2 antibiotics that are available in the United States for fish farmers. We've emphasized vaccinology to vaccinate fish and prevent disease. We've looked for husbandry practices that minimize stress. And then if necessary, we can quarantine and depopulate fish farms. That would be an extraordinary event. So that's the preliminary. Now, I'd like to explain a little bit about Clear Springs and where we're located, and a little bit about the company. Clear Springs is located up here in south central Idaho. Approximately here, we are located along the Snake River, which is about a 1,000-mile long river that joins up, merges with the Columbia River, and then goes off, it then empties into the Pacific Ocean. So it goes along here, up here, joins with the Columbia River, out here, and out to the Pacific Ocean. We operate 8 very large fish farms. The largest one is our Box Canyon farm. We receive an extraordinary amount of fresh water. It is all spring water. We receive 300 cubic feet per second of water that goes through that farm to grow fish. We also use the water to generate electricity. Here, it's used to grow fish, and then somebody else has used the water to generate electricity in other And that water is discharged into the Snake River. This is another fish farm, or group of fish farms. It's called the Clear Lake Complex. Our processing plant is located right here. We have a small broodstock facility right here. Yeah, so over here, and then our Crystal Springs farm right here. Clear Springs is the largest trout producer in North America, and probably the single largest trout producer in the world. We produce 26 million pounds, or about 12,000 metric tons per year of rainbow trout that go strictly to, is strictly used for human consumption. So all those fish are processed at our processing plant. I guess the processing plant is reversed. The processing plant is right here, and our broodstock facility is over here. So for current permitting, again, our focus in the United States is for manufacturing fish farms. But my impression was I needed to visit a bit about effluent management. We are regulated by the U.S. Environmental Protection Agency. We have mandatory national lakes is preventing pathogens from entering the fish farms. But my impression was I needed to visit a bit about effluent management. We are regulated by the U.S. Environmental Protection Agency. We have mandatory National Pollutant Discharge Elimination System permits, NPDES permits, and those are science-based. Our biggest effluent control is the discharge of nutrients, and we use feed and good fish husbandry to ensure that we meet the state and federal requirements. We also are required not to injure endangered species. There are some snails in the area that we have been determined to be endangered. That means they perhaps might become extinct if they get damaged much further. And so we are required not to damage them. Our permit requires that we use best management practices in growing the fish. And we have to report monthly to the EPA and the state of Idaho what our discharges are. Discharges of nutrients and phosphorus then, and total suspended solids. We have to always be meeting state and federal water quality standards. And there are very significant penalties if we fail to meet those requirements. To use water in Idaho and much of the West, you have to get a water right, or a bunch of water rights. And Clear Springs has a bunch of water rights that enable us to use water non-consumptively, that is to grow the fish and return it back to the public water resource, that being the Snake River. So the key in the United States, and certainly at Clear Springs, is to have a rigorous inspection program and certification program to ensure that we're not introducing foreign animal disease type pathogens. To import eggs into Idaho and Clear Springs, we do have our own broodstock program. We are a vertically integrated company, so we grow our own eggs, but at times we need to bring in other eggs to help us out. The thing about fish farming makes aquaculture so beneficial internationally and certainly in the United States is that fish farmers can provide seafood to consumers year-round. And the reason we can do that is because we have a continuous supply of eggs to feed the farms, to feed the processing plants, to feed the market. So we have to get 5 to 6 different permits from the state governments and the federal government to import eggs from Denmark, for example. Those permits require that an expert, a technical expert, test the eggs or test the female and maybe the fish for various specific pathogens. In Denmark, when we get eggs from Denmark, we get a certificate of origin and health. Well, they have tested for IPN, for Flavo, for IHN, for VHS, you name it. It seems like they've tested those eggs for just about everything. So the results of all this effort have been that we have a biosecurity program at Clear Springs, and other farms do in Idaho and in the U.S., that prevents the introduction of foreign animal diseases or pathogens that we don't otherwise want, that we don't have. We have no raceway disinfection. Again, it's not practical. You can't disinfect ponds. You can't disinfect the ocean where net pens are. You can't disinfect lakes. And you can raise trout in lakes, raise trout in the ocean, in net pens. So we don't do that. The other problem with disinfection is there's no validated assays for measuring the presence of fish pathogens in effluent water. The state of Idaho will take Clear Springs trout when we have extras, which isn't too often, but when we have extras, and they will stock those fish into their public waters, into the Snake River, into lakes around the state. The state of Idaho does the same thing with their own farm fish. They will stock their waters with their fish. They will contract with other fish farmers to grow fish specifically for them. Other states will do the same thing, not with Clear Springs fish. Ours are too precious to be taking them live across to other states to stock in their waters. But some businesses, like in Colorado, will grow trout specifically for selling in Nebraska or Missouri, places like that, because those states love those fish. They do have to go through a certification program, which is very expensive with a fish farmer, but that's what happens. So the consequence, particularly nowadays, of all of these certification programs is that we do not see epizootics of disease in wild fish that in any way can be attributed to freshwater fish farming. Now, in the Great Lakes, in the past 5 or 6 years, VHS virus appeared in the Great Lakes. It affected lizard shad and alewife, a very different kind of fish than a salmoniid. And it caused significant mortality of those fish, or it was associated with significant mortality of those fish. And it did not occur in fish farms. And the U.S. government, the USDA, instituted they stopped the movement of live fish from the Great Lakes area into the rest of the United States. And states instituted programs to make sure that VHS virus did not enter state waters. That virus has stayed in the Great Lakes. That was in the wild fish. The question, though, for the experts, is why did those alewives or lizard shad have disease? Why did they die? Was it something in the environment? maybe a pollutant in the Great Lakes. Stress those fish. Hard to say. So one other program, the evolution of fish health management in the United States continues. Just in the past 2 years, the National Aquaculture Association, which is a trade association that I'm intimately involved with, and the U.S. Department of Agriculture, for some reason their logo is not showing up here, we have partnered to develop a new program for managing aquatic animal health in the United States. It's not that the existing program doesn't work. It works extremely well. For some fish farmers, though, that program is very, very expensive because they have to meet not only the federal requirements, but the state requirements. So we wanted to look for ways, maybe there was a way to better do this, to better manage the health. Other producers in the United States wanted to move live product internationally. Some of you have heard of Trout Lodge. They wanted to be better able to do that. There are some shellfish, so some oyster producers, that also want to move their live product to France, for example. So we got together. We have a team of experts, myself included. We have USDA Animal Plant Health Inspection Service experts, epidemiologists, and people who work with terrestrial animals a lot and with poultry a lot. Sometimes they get diverted to deal with highly pathogenic avian influenza, so they get diverted away from the fish to the poultry. Figure that out. We've developed what's called the Commercial Aquaculture Health Program Standards. There are 5 principles in that standard. First one is the formation of an aquatic animal health team for each farm. So if you want to move fish, live fish from Idaho to Utah, and you want to do it as expeditiously as possible, you would form this team, and it would be composed of a farm owner, a veterinarian, American Fisheries Society fish health pathologist, or fish pathologist. It could be a laboratorian. It could be somebody who does the testing for viruses. That could be, in the United States, we have academics that are called extension agents. They could be part of the team. The whole idea is to get an expert team together to do site-specific risk characterization management develop a management program, to institute the appropriate level of surveillance, and if there's a threshold of mortality occurs, to institute a very thorough root cause analysis of why that disease, why those fish died, and if it's an OIE, an International Animal Health Organization pathogen, listed pathogen, they would have to report that, and then there would be an appropriate response, all designed prior to the disease outbreak. There'd be a site-specific health plan in which communication mechanisms would be identified, there'd be the risk management program, surveillance, investigation, and response. Interestingly, on this, not everything is showing up. So, if there is any interest, and this is on the PowerPoint, my understanding is that our presentations, and particularly mine, will be translated into English. All this information about TAPS is available on the USDA website, and so that's where you can find it. So,